is, this one we are trying to propose the location and the diameter of the orifice, and also the size of the orifice. The H0. The H0 is actually from the maximum water level of the orifice to the maximum water level of the OSD to the center of the orifice. So where is the maximum water level? It's actually at the secondary outlet. The secondary outlet is the invert level of the secondary outlet is the maximum water level. So from there, calculate from there, then we go to the center of the orifice. Here we need to firstly decide where will the orifice be located. This is how we get the action. Firstly, we need to know where we want to put the orifice. Normally it's at the most bottom, normally. This is H0. Then the other input we need to give to the program is the orifice diameter. Then the program will do back calculation and recommend how many orifices is needed. Then here we can input according to the proposed, or we can input more. Then the user need to specify the ARI year for the secondary outlet. Normally it's 50 years, which is also recommended by MES. Secondary outlet normally we use 50 years. For secondary outlet, we use 50 years. That means this secondary outlet is used to handle 50 years storm. And then the broad crystal wear coefficient, and then the H, the overflow height, and then the program will give the required storage. This is the required storage. The program will automatically propose the wear width. The wear width is the wear. The width is perpendicular to this diagram. The wear width. Now we proceed to step 4, quantity detailing. The input data needed is, we need to know whether we want to design a rectangular or a circular OSD. After that, we need to propose the physical dimension, like the length, width, depth, and size slope, if it is above ground OSD. Then based on the physical dimension we key in, the program will calculate what is the volume provided. Step 5, pipe discharge design. Here the input needed is the size of pipe and the gradient of pipe only. If the combination doesn't work, there will be an error message pop out. And now we look at, we review the model result. There are 4 types of output. The first one is texture report. Texture report is full detail calculation. In all of our software, the name being used here, texture report, always refer to full detail calculation. This one is texture report, and there's a summary report, summarize all the important design results from texture report. This one is summary report. And the detailing. Left hand side is above ground OSD, right hand side is below ground OSD. Both detailing are basic, simple detailing. The engineer needs to later touch up based on his or her design specification. And then the last output is the pre-development and post-development IDF graph and the SSR storm duration graph. So the outputs can be exported either in Word document or PDF. User can also use batch export. The difference between export and batch export is, if we click the button export, it will export what we see on the screen. If we click batch export, it will export all 4 types of output in one time, in one batch. Okay, now I'll proceed on to OSE modeling demo. Firstly, we create a new project. This is our file menu. This is a file menu. It stores all the basic things like new a project, open a project, save a project, close, backup. Backup means to flip a project. Okay, we create a project, click new. Let's say give it a name. Contact demo, OSE demo. Choose the location to be at desktop or any other location, and then click OK. And then click OK again. So a folder will be created on the desktop, the location that I specified. This is the folder. Okay, so we can start on any four of them. You can jump, you can start one first or grandmother house in first. Okay, first we need to decide